Hello, good day. Welcome back to another math video. Today we are going to talk about logarithm. So to start with, when we talk about logs, this is just equal to exponents. So again, with this in mind, we can answer the questions about logarithm. So for instance, we have here the log of 16 with base 2 is equal to 4. This is asking us for an exponent. So it is asking us what exponent do we put on the base of 2 to get 16. So again, this is telling us or asking us what should be the exponent of 2 that will give us 16. In this example, that is just 4. The same is true with here. This is telling us or asking us what should be the exponent of our base 3 to get 1 over 9. And then that is actually negative 2 because we know that 3 raised to the negative 2 is just 1 over 9. And here we are also asked what should be the exponent of 4 that will give us 1. So again, that is just the entire idea of logarithm. So logs is equal to exponents. So the question here is, how do we rewrite um, exponential equations to logarithmic equations? Or how do we write from the exponential form to logarithmic form? So for instance, we have, or you have, um, an exponent. We have y exponential form is equal to b exponent x. So again, this is our exponential form. Now, to rewrite this one into a log form or logarithmic form, all we have to do is again, write the word log. And then, in this example, our base is actually what? This is our base, right? Just, this is our base. Alright? So again, we are going to write our base as our subscript. So, log. Then we have the base, b. And then, whatever is here at the opposite side of the equation, write it after our base. So we will write y and then equals the exponent. Alright, so basically again, from the previous slide earlier, this is telling us or asking us what is the, or what should be the exponent of b to give us y. In this example, again, this is just b exponent x equals y. Right? So, itong dalawa, they are just, again, the same. Right? So, again, that is how we write um, exponential form to logarithmic form. So, let's have some examples for us to better understand the concept. So, I have here series of exponential form, and then our task or our goal here is to rewrite them to its corresponding logarithmic form. So, we have here, again, 10 cube is equal to 100. In this example, our base is 10, right? So our base is 10. 3 is our exponent, and then again, this is our equivalent. No? 10 cube is 1000. So to rewrite that one into logarithmic form, again, we will have log. Write the word log. Again, log, and then this is our base. And then write 1000, and then equals the exponent. Again, this is our exponent. Alright? Exponent. Number 2. We have 2 raised to the negative 4 is equal to 16. So what we are going to do is, again, write log. Base is what? 2. And then 1 over 16 equals negative 4. I think I have the answer here. Alright. So you have log base 2. Then we have 1 over 16 equals negative 4. How about this one? Let me just erase this. How about number 3? We have 2 raised to 5 is equal to 32. Again, we will have log base 2, and then we will write 32, and then equals the exponent, which is 5. Number 4, we have what? Log of base 3, 9 equals 2. How about number 5? Alright, so we have log base 3, 1 over 9 equals negative 2. And then the last one, number 10, we have log of base 10, then 1 over 100 equals negative 2. So again, that is how we rewrite exponential equation to its logarithmic form. Now, let's try to do the reverse. So I have here series of logarithmic equations, and then our goal here is the inverse again. Rewrite this one or transform this one to its corresponding exponential form. So first thing that we should do is identify our base and identify our exponents. So in this example here, this is our base, right? This is our base. And then again, this is our exponent. After the equal sign is our exponent. So we will write what? Our base is 4. Our exponent is 3. So we will write 4 cubed is equal to 64. This is our answer. Next, we have log of 6 base 36 is equal to 1/2. What is our base? Base is 36. And after the equal sign, we have 1/2. So this will be our exponent. So we will write 36 raised to 1/2 is equal to 6. Number 3. What is the base? Base is 2. Exponent is negative 2. So we will write 2 raised to the negative 2 is equal to 1/4. And then number 4. Base is 2. Exponent is 3. So we will have 2 cubed is equal to 8. Number 5. Base is 8. Exponent is 1/3. So we will write 8 raised to 1/3 is equal to 2. And then the last one, we have base is 2. Exponent is negative 3. So we will have 2 raised to negative 3 is equal to 1/8. Why is it in black? But then again, this is the correct answer. Again, 2 raised to the negative 3 is equal to 1/8. So again, this is how we rewrite or transform exponential equations to its logarithmic form and vice versa. Next, we will discuss about the different properties of the logarithm. Again, take note that since the logarithm is the inverse of our exponential or exponents, basically all the properties, the rules of logarithm are derived from the laws and rules of exponents. So for instance, we have here, number 1, logarithm of a product. So it is said here that the log of mn with base b is just equal to the log of m with base b plus the log of n with base b. Now remember, when we have our exponents, when we have a times a, this is equal to a squared, right? So again, what we did here is we actually add the exponents. Diba? We have an exponent here, 1 and 1. So again, 1 plus 1 is just 2. Again, we added the exponents. And remember earlier, we said that logs is equal to exponents. So basically here, when we multiply m and n, we are going to add them, right? So let's have some example. So for instance, we have the log of base 6 tayo. Then we have here 5 times 3 based from our logarithm of a product. This is equal to what? A log of base 6 5 plus the log of 3 with base 6. They are just the same. Alright? You can actually try to use your calculator to evaluate this one. And I guarantee you the two expressions are the same. Let's have another example. We have log of 7 times 6 with base 9. Sorry, it should be 9. Oops. This is 9. This is equal to, again, based on the logarithm of a product, we have what? Log of 7 with base 9 plus log of 6 with base 9. Again, based from our logarithm of a product, these two are just the same. We have the logarithm of a quotient. So again, going back to our exponents, if we have a cube over a, this is what? Equal to a 3 minus 1, or a squared. So again, we subtracted the exponents if we are dividing exponents with the same base. So again, remember, when we talk about logs, this is just equal to the exponent. So again, when we divide, we subtract. So if we have here the log of m over n with base b, that is just equal to the log of m with base b minus the log of n with base b. So let's try some examples. So for instance, I have here the log of 6, 5 over 3. Based from the logarithm of a quotient, this is just equal to what? The log of 5 with base 6 minus a log of 3 with base 6. Right? Next example, we have log of 7, and we have 7 over 5. This will give us log of 7 with base 7 minus a log of 5 base 7. So again, that is according to our logarithm of a quotient. Next, we will have the logarithm of a power. Now remember, when we have exponents, we have a squared raised to 3. This is equal to a raised to 6. We multiply the exponents, right? Now, in log, what we will do is we are going to transfer our exponent down here, right? Right before the log. So for instance, we have log um, 3 squared with base 6. This is just equal to 2 log of 3 base 6. Again, this is according to our logarithm of a power. Next example, we will have log of 7 squared base 5. This is equal to 2 log of 7 with base 5. Alright, I have here additional properties of our logarithmic properties of logarithm. So remember, in our exponents, remember that raised to a number raised to 1 is the number itself. So if we have um, a raised to 1, this is just a, right? Or if we have 2 raised to 1, this is just 2. So again, using this concept, if you are going to rewrite this one into its logarithmic form, this is just what? Um, Again, we are going to write the word log, and then our base is 2, right? Equals 1 is our exponent, and then we have 2, right? So we have the log of 2 with base 2 is equal to 1. So the same is true here. If we have a raised to 1, that is just a. So when we rewrite this one into its logarithmic form, this is just log of, after the equal sign, we have the a. I will write that one as a big letter A for us to see the difference now. So a with base a equals 1. So this is saying or telling us that every time you will see an expression, a logarithmic expression that says log of, example, log of 6 with base 6. Notice that the number after the base and the base are the same. This will always give you 1. Alright? No doubt about that one. So another example, if you have log of 7 with base 7, this is just 1. Right? Again, you can try whatever number you want, but then again, if the base and the number after the base of every log expression are the same, it will always give you a 1. The another is, remember also that any number, of course, except 0, raised to a 0 is equal to 1. So in our exponents, if we have a raised to 0, this is just 1. Or 1 raised to 0, this is just 1. So again, any number except 0 raised by 0 is always 1. So if we are going to rewrite this one into our exponential form, this is just what? Log. Our base is a, so log of base a. And then our exponent is 0, so that is equal to 0. And then after the equal sign is 1. So every time you will see this pattern, any base, and then after the base you have 1, it will always give you a 0. So for instance, you have log of 1 with base 2, this is just 0. Alright? Log of 1 base 20, this will give you still 0. So again, these are the different properties of our logarithmic functions or expressions. Now, we are going to apply the different rules and laws of our logarithm to expand a logarithmic expression. Now, when we are asked to expand, basically we are just going to make use again of the different properties. Now, here we have log of 6 times 11. So again, log of 6 times 11. Now, if you notice here, we don't see any base written here, right? If this is the case, this is always 10, right? So, automatic, if you are not seeing any number here, this is base 10. Alright? So, again, this is a multiplication, log of 6 times 11, based from our product rule or product law of logarithm. If we are seeing this one, this is just equal to what? We have log of 6 multiplication, so we need to add, right? So log of 6 with, again, base 10 plus log of 11, right? So again, that is our answer. So again, this is our answer. Next, we have log of 5 times 3. So again, multiplication, we are going to add. So we will write log of 5 plus log of 3. Again, this will be our answer. Next, Alright, so we have log of 6 over 11 raised to 5. Now remember here, if you're seeing this one, um, this is actually a combination of the power rule. We have an exponent and we also have division here. So we will just rewrite this one first. So this is just equal to log, distribute the 5. This will become 6 raised to 5 over 11 raised to 5, right? And then since we are dealing with division, we are going to subtract. So we will get what? Log of 6 raised to 5 minus log of 11 raised to 5. Alright? Now, we're not done yet. We actually have an exponent here, and based from our power rule, if we have exponents, we are going to what? We are going to transfer the exponent before our log term. Alright? So what will happen is this. We have 5 log of 6 minus 5 log of 11. So that will be our answer. Alright? Let me just box this one. Alright. So that will be our answer. 5 log of 6 with, again, base 10. And then minus 5 log of 11 with base 10 as well. Number 4. How do we approach this one? We have, again, multiplication. So we are going to expand that one first. We will write log of 3. Multiplication, so we need to add, right? So plus log of 2 raised to 3. And then we have here an exponent. We have here an exponent. So we are going to simplify that one. This will become log of 3 plus, again, transfer the exponent before our log expression. We have 3 log of 2. So this will be our final answer, right? So yeah, we have log of 3 plus 3 log of 2. Number 5, we have here again division. So we are going to subtract. So this is what will happen. We have log of 2 raised to 4 minus log of 5. And then simplify again. We have an exponent here. So we are going to write that one before our log. So what will happen is we will have 4 log of 2 minus log of 5. That will be our answer. Alright, so this is our answer. So again, that is how to expand any logarithmic equations or expressions. Now, if we expand, the opposite of expanding is condensing. So again, we are going to make use of the different properties of our logarithm to condense a logarithmic expression. So for instance, we have here log of 3 minus log of 8. We have a minus sign. So what will happen again if we are subtracting two logs? We are what? Dividing. So basically what will happen is we have log of 3 over log of 8, or basically we have log of 3 over 8. So again, this will be our final answer. So final answer. Next, we have log of 6 over 3. Now this is a bit interesting. If we are going to break this particular log expression, this is just equal to what? Um, I'll present first the answer so that again I'll know where to write. So we'll write here. This guy here, eto, um, log of 6 over 3 is just equal to 1 third log of 6, right? So we have 1 third log of 6, and based from our power rule earlier, if we're going to do the reverse, we are going to write it here, right, as our exponent. So what will happen is we have log of 6 exponent 1 third. And then what is 6 raised to 1 third? This is just equal to the cube root of 6. So again, this will be our answer. Or if you have this answer, actually this is still correct. Alright. If we stop here, again, this is still correct. It will depend on the requirement of the teacher. But then again, as for me, both are actually correct. Alright. Next, we have here 4 log of 3 minus 4 log of 8. So again, we have a number before our log expression. And then what we are going to do is make this as our exponent, right? So what will happen is we will have log of 3 raised to 4 minus log of 8 raised to 4. Right? And then since we are actually subtracting, we are going to divide, right? So what will happen is we have log, then we have 3 raised to 4 over 8 raised to 4, or simply log of 3 over 8 raised to 4. So this will be our answer. Alright? So, ito yung answer. Yun in red. Alright? So, that's it. I think we still have items here. Alright. And this will be the last one. So, you have log of 2 plus log 11 plus log 7. So, this is just a series of addition. So, again, since we are adding things or adding logarithms, we're going to multiply. So, this will give us what? Log of 154, or why is it 154? Because we have log of 2 times 11 times 7. So what is 2 times 11 is 22 times 7 is just 154. So again, we have log of 154 as our answer. Alright, number 17. Meron pa pala. So we have log of 7 minus 2 log 12. So basically, we have subtraction here. So what will happen is we are going to divide. So we have log of 7 over 12 raised to 2. Alright? Because again, we have here a 2 before the log. So we are going to make that one as our exponent. And or let me just erase this because tama naman yan. Or if you want to extend this one or simplify more, this is just equal to log 7 over, what is 12 squared? That's 144, right? Am I correct? 144. Yeah, that's 144. So this will be our final answer. So this is all about logarithm, the concept, the different laws, the different rules, and then we expand logarithm,